Morning to all. Today we are going to see about third part of your moving charges and magnetism. So in this one, I just going to explain about the magnetic field due to current carrying straight conductors. All important problems which were asked in previous year questions in both the NEET and JEE mains, not JEE mains, NEET and this one EAMCET. I am going to explain about this. You just concentrate here, and some of the shortcuts and some important highlights will be shown in this video. Right now, problem here is see this one. This is concept oriented. You just try to understand the concept here. If you are having any doubt, you just pass your comment and your doubts on the comment section. Let me try to explain this one in little more detail. See here, a horizontal overhead power line. You just consider about a power line is at a height of 4 meters from the ground. From the ground, you just consider about the horizontal line power line which is from the ground, that is the meter here is 4 meter, and carries a current of 100 ampere from east to west direction. Now see here, current direction is moving from east to west direction. This is little important. You just highlight this point, right? And next one, the magnetic field is directly below it. So the magnetic field is directly below it on the ground. What is that magnetic field, and which direction the magnetic field is moving over here, whether it is a northward or southward? That what we are going to see here. The first one, you just try to understand. Let me tell you the concepts here. See, for this one, this is about the Ampere's law. According to that Ampere's law, see this one, the surface integral of beta dl is equal to mu naught into I. You just remember this one. Beta dl here is mu naught into I, and where I is about the current which is flowing towards the surface. See here, the current which is flowing towards the surface, that is I mentioned here is in a cross mark, that is like appears in like this mark. So that, so this one here is positive, and dotted with a circle here is the current which are moving outwards from the surface. So that is negative here. See, I2 and I3 are negative, which is moving outward from the surface. I1 and I2, I4 are the current which is moving towards the surface. And we are not considered the current which is flowing away from the surface, that can be neglected here. See, from this one, I here is, this is the formula here. And next one, you just concentrate this one. From this one, how you are getting that formula, let me tell you here. See, next one here is you just consider about the diagram here. See this one, this is about the current which is flowing towards here. See, I just mentioned in this case, current which is moving, this is a 100 ampere of current is moving over here from the ground. I just mentioned here, from the ground, this is about what you have given here is 4 meter from the ground, which is 4 meter. Now the current is moving from, see, I just mentioned here, east to west direction. Now according to this one, you just mentioned here, this one here is north and this one here is south. So this one north and south means this one here is east and west. So I just mentioned here, this is north and this is south here. So you just concentrate here. Whenever the current is moving from, see this one, you can understand here, the current is moving from east to west direction, right? Now according to right hand palm rule, you just consider here, this is about the current direction, and this one, the force will be exerted outward from the paper. You can see here, outward from this board, the force will be coming out, and this one is about the direction of the field. See, what they are asking here is the magnetic field below it, below the magnetic field already mentioned here, and what direction it will be. See, from this one, the magnetic field direction which is moving towards the south direction. So you can understand over here. Let me tell you in this concept. First one, see here, beta ds I just mentioned here in this case. This one I just mentioned here. So b dot surface integral of b dot ds or even a dl is equal to, what you are having here is mu naught into I. Now b into surface integral of, this one I just mentioned here, surface integral of dl. That one, this is in a circular shape, that is surface integral here is 2 pi r, that is gives about this circumference. So from this one, instead of ds, what I'm going to mention here is 2 pi into r, that one will be equal to mu naught into I. See, from this one, b is equal to mu naught I divided by 2 pi r. Right. Now you just substitute all the values here. I just mentioned this one. B is equal to mu naught here is already they have given in the question 4 pi into 10 power minus 7. And I current value how much they have given, that is 100 ampere of current, and whole divided by, I just mentioned here. So 2 pi into radius. What they have given about radius here. See this one. I just concentrate here. So this one in this case from magnetic field which is moving from radius is nothing but that's what I have mentioned here. So magnetic field is moving towards the ground, that is about 4 meters. So here is answer in this case I just mentioned as 4 meter. Now this one I just mentioned here, this is pi, and pi will be cancelled here, and this 4 and this 4 will be cancelled here. From this one 2 and this one will reduce for 50. So from this one what you are going to have here is 50 into 10 power minus 7 Tesla. But you just see that option it is not there. So you just mention here 5 into 10 power minus 6 Tesla. So answer in this case here is minus 6 Tesla. And this one southward already I have mentioned from the direction amperes right hand palm rule. So this is about the magnetic field direction towards south. Is the magnitude of B from a conductor carrying current 35 ampere. See here, this is 35 ampere. Magnitude about a magnetic induction or a magnetic field from a conductor of 35 ampere. So this one simple concept, when a current passing through a conductor which is having a distance they have mentioned here 20 centimeter, that will produce a magnetic field. So what is that magnetic field in Tesla? We are going to find out here. See this one already we have seen in a conductor, current carrying conductor. In the previous problem we have seen this one, that is a B is equal to mu naught I divided by 2 pi into R. This one 2 pi r, in this case a mu naught value already you know, this one I just mentioned here 4 pi into 10 power minus 7, and the current what they have given here is 35 ampere and divided by 2 pi into, and radius what they have given here is 20 centimeter, that is 20 into 10 power minus 2 meter. From this one I just cancel here, this is for the 2 times, and from this one again I just cancel here, that is for see I just mentioned here in a different color. This one, this 2 and this 2 will be cancelled for 10 times here. Now this one, this is 10 times, and this one will be cancelled here for minus 5. So what you are going to have here is this 10, this 10 divided by 35 divided by 10 here is 3.5 into 10 power minus 5 Tesla. So answer in this case here is 3.5 into 10 power minus 5 Tesla. The next problem here is a current of 5 ampere flows downward in a straight conductor, straight vertical conductor. This is little important and little concept oriented. You try to understand this concept. See here, in a wire, when a current passing through the wire, first concept here is around the wire it will produce a magnetic field. Now this one, this is produce a magnetic field, and next one here is the earth horizontal flux they have given BH value, that is a 2 into 10 power minus 7. Then the neutral point occurs where it is going to occur. See this one I just mentioned in this case. Say for example in a straight conductor, vertical conductor they have mentioned here. So I just mentioned here in this case of vertical conductor. In a vertical conductor, when a current passing through here is I just mentioned as I. Whenever the current passing through the conductor, around the conductor, what you are going to have here is there will be a magnetic field. I just mentioned here. This is about the magnetic field, and this one, and this is the point where you are going to get the total radius of the magnetic field around the coil. And this one they have given X magnetic field. See this one I have mentioned here is S magnetic flux density. I just mentioned here BH on this point. See here BH on this point they have given the value, and where it will produce, see here, this will produce a S magnetic field horizontal flux towards this direction, and because of the current passing through the coil, see here, uh, see here this one, when a current passing through this coil, because of the current passing through the coil, that will produce a magnetic field in opposite to the direction. Both current both this magnetic field and horizontal magnetic fields are cancelled to each other at a particular point. That part is called as a neutral point, this one. Now from this one, at what distance the neutral point is produced here, that's what they are asking here. At what distance, this is about R. That one we are going to find out. In this case, let me tell you, in this case For this one, first one here is B value because of the magnetic because of the current that passing through the conductor that produce a magnetic field. I just mentioned here B is equal to mu naught I divided by 2 pi into R. You just substitute all the values. Mu naught value here is 4 pi into 10 power minus 7 into current value. What they have given here is 5 divided by and 2 pi into R. That one we are going to find out here. From this one I just cancel this. What you are getting here is 2. So what you are getting, that answer here is 10 into 10 power minus 7 divided by R. Up to this distance what you are getting here is that magnetic field. This magnetic field will be compensated by the, see, this is the magnetic field up to this distance. This magnetic field will be compensated by your horizontal flux density. So both are opposite to each other, so this will be cancelled to each other. So what you are getting, that answer in this case I just mentioned here. So this one B will be equal to B of H. Now already they have given here, I just mentioned this one, the B of H value here is 2 into 10 power minus 7, and this B value I just mentioned here 10 into 10 power minus 7 divided by R. That one will be equal to, already they have given 2 into 10 power minus 7. Now 10 power minus 7, 10 power minus 7 will be cancelled here, so R is equal to 5. So this one you just cancel here. What you are getting here is 5 is that answer. So R is equal to 5 meter. Now from this one you can understand here, this first two options won't be there. See this one, these first two options won't be there. Either C or D will be there. Now this one I just mentioned here, these two options are not there, either C or D. And for this to understand better, let me tell you some concept over here. See for this one, see here, a null point due to a very long straight conductor. See this one, this is about, see, in a very long straight conductor, current carrying conductor placed in a S magnetic field. See, this is about S magnetic field, already they have given. This is about the current where it will produce the null point. This is about the null point. And see here, when a current that is passing through the conductor in upward direction, means null point will occur in west. Similarly in this case, when a current is passing through downward direction, null point will be produced in east direction. So remember these 2 points. See from this one, so from this one what is that answer here is either C or D will be there. I just mentioned this one. Now from this one you can understand here either C or D. So this one here is second option, that is about downward direction, that is E. So answer in this case here is this one. Now the next problem here is a current 1 by 4 pi ampere is flowing in a long straight conductor. See this one, in a conductor, when a current passing through it, around the conductor magnetic field will produce. Now this concept you understand here. The line integral, listen here, what they have given here is line integral. This is not surface integral. Surface integral means B dot ds should come. Line integral means B dot dl. Remember this one. This is line integral. Line integral means B dot dl. Surface integral means B dot ds. This one here is area, that is in meter square. This is length, that is in meter. Now of magnetic induction around the closed path enclosing a current carrying conductor. This one surface line integral of this one I just mentioned here, B dot dl is equal to, what you are going to have here is mu naught into I according to Ampere's law. This one 4 pi into 10 power minus 7, and what you have given the current value here is 1 divided by 4 pi. So 4 pi will be cancelled here. So what you are having here is 10 power minus 7. This one here is integration of B dot dl. So what they are asking here is magnetic induction. Magnetic induction means B is equal to 10 power minus 7, and the unit, already they have given the unit here is integration of dl. So that's what you are going to have. So the answer here is 10 power minus 7. So here magnetic field, already what you got here is, that is in Weber, right? So here is Weber per meter. So what you are getting, that answer here is Weber per meter. Now the next problem, two long parallel wire are separated by a distance of 8 centimeter. Now you just consider two wires which are separated by a distance of 8 centimeter, and each wire carries a current here is 3 ampere and 5 ampere. The distance of null point from the conductor carries a large current. See, in this one they are concentrating about the large current carrying conductor. When a current is flowing in the same direction, both the way the current will be flowing in the same direction. See here, in this case This is about the first wire that carries 3 ampere of current. This one is second wire. This carries 5 ampere of current. The distance between this one, that is D is equal to R, I just mentioned as 8 centimeter. Now, in between, whenever the current flowing here, that the center point, null point is created. This one. See, for this one, let me tell you to understand better this one. In a conductor, whenever the current flow in a conductor, see, you just consider this one. In this case, around the conductor, there is a magnetic field. For the first one, you just consider this is the magnetic field limit. That distance here is 8 centimeters, right? Now, in between 8 centimeter, not exactly 8. Now, next one, the second conductor you just consider here, the magnetic field produced around here is this one. In between these two conductors, that is 8 centimeters. Now, in this case, it creates a null point. For example, from the what they are asking here is in this one you just consider here the distance of null point from the current carrying conductor, uh, from large current carrying conductor. See, from this is large current carrying conductor 5 ampere, from here to here, that is x. We are going to find out x. See, the total distance in between them, that is r. R means value here is 8. So here is x is the distance we are going to find out. So r minus x. This one from null point to the first conductor here is r minus x. Now we are going to find out in this case. Let me tell you to understand better. I just mentioned in this case. See, for D1 I just mentioned as from lower current. That one I just mentioned as r minus x. That is nothing but 8 minus x here. And D2 here is I just mentioned as x, right? Okay, now next one. See, whenever the current flowing in a conductor, it produces a magnetic induction. That one I just mentioned here. B1 in this case, that is about the first conductor. Mu1 I1 divided by 2 pi. This one here is D1 distance. Okay, and the second one I just mentioned here, B2 is equal to the same one, mu naught I2 divided by 2 pi D2 here. Null point in this case, B1 will be equal to B2. See this one, this is null point condition. B1 will be equal to B2 for a null condition. Null condition I just mentioned here. Okay, now I just substitute value over here. B1 value here is a mu naught I1 and 2 pi. D1 here is what they have given here is R minus X, and mu naught I2 divided by 2 pi. D2 here is what they have given, that is X. Now from this one, what are the common terms that we cancel over here? See, this one mu naught will be cancelled here. This 2 pi will be cancelled here. See, from this one, what I'm going to mention here is I just mentioned here I1 into X will be equal to I2 into R minus X. Now this one I1 value here is what they have given, 3 ampere of current, 3x. That one will be equal to I2 here is 5 ampere of current. R value here is 8 minus x. Now you just simplify here. 3x will be equal to 40 minus of 40 minus 5x. So total what you are having here is I just mentioned in this one remaining here. See, a is 3x plus 5x here is 8x. That one will be equal to 40. So x is equal to 40 divided by 8. So what you are going to have here is 5 centimeter. So x value, that means what you have given here is from this one here is 5 centimeter. That is that answer. The next problem here is similar like a previous problem, but one important concept here. You just try to understand this one. Two long straight parallel conductor, and distance they have given 10 centimeter apart. Previous one what they have given here is they have given only 8 centimeter, but this time they have given 10 centimeter here, carries a current of 5 ampere. See, in both the conductor are having the same current, and each in the same direction. Then the magnetic induction at the midpoint. See here, this one similar concept, but here in this case what they have given here is current. In this case, this one here is 5 ampere of current, and here also 5 ampere of current. Before it one is about 5, another one is 3, but here is same amount of current. In this case, from this one the midpoint here is this one also produce the same, and this one also produce over the same. See here, which will be moving like this, and here also moving like this. From this one it will be moving like this, while moving here this is in opposite to the direction, so that both will be cancelled to each other. So that what happened here is, see for example, this is 1 and this is 2, I just mentioned here. The magnetic field produced over here is, I just mentioned here, mu naught I divided by 2 pi r, right? This one the same concept I just mentioned here, mu naught I divided by 2 pi r value here is this one I just mentioned here. For example, both are at the same distance, right? So I just mentioned here r only, and for b2 is equal to mu naught I divided by this one also the same distance r. I and I both will be the same, but in this case b1 will be equal to b2. You just substitute this value b1 minus b2 equal to 0 here. Both are same value, so both will be cancelled together. So answer in this case here is 0. This one here is most important questions. So definitely such type of question from this chapter you can have. See here a wire in the form of a square of a sides they have given a. So side of the square here is a, and the current passing through the square here is I. Then the magnetic induction at the center of the square, and additional what you have given, the permeability of free space here is mu naught. See, I just mentioned in this case. See, this is about the wire which is made up of the square, and the side of the square what they have given here is A. So from the center, what is that magnetic field from each side when a current passing through this? See here, in this case, the current is passing towards the side. We just concentrate on this one, only one side. So from one side means from this point to here, that is R here is A by 2. Now for this one, let me tell you here, this concept, hope you remember this one. The magnetic induction due to a straight conductor of a finite length, this one finite length, which is perpendicular distance here is r. So for this one, see here 45 degree, if you are considering this angle, you are going to use here is sine theta 1 and sine theta 2. See to that current direction is this direction, so that the magnetic field, see here they have mentioned the magnetic field towards the paper. See, opposite to the direction means, it's opposite to the direction means which will be away from the paper. So you just consider here theta 1 and theta 2 here is sine theta 1 and sine theta 2. If you consider about alpha and beta, that means this angle and this angle, if you are considering over here, you have to mention this one cos alpha and cos beta. For this one, let me tell you here, for the first case I just mentioned in this one, for the first one here is b is equal to, see I just mentioned here, see b is equal to mu naught I divided by 4 pi r. Here is the distance perpendicular distance here is a by 2 into c here sine of 45 degree plus sine of 45 degree. Sine of 45 degree plus sine of 45 degree here is, I just mentioned this one alone, that is 2 sine of 45 degree. 2 into sine of 45 degree. That one here is sine of 45 here is 1 by root 2. So 2 into 1 divided by root 2. So root 2 here is cancelled, only root 2 will be there. See this one here is, I just cancel this one, this is for 2. See for this one what you are going to have here is mu naught I divided by 2 pi a into, so what you are going to have here is root 2. Now in this root 2 you can cancel over here for root 2 times. For this is for only one direction, I just mentioned as one. Say for example this is 1, 2 and 3 and 4, all are same in this case. So what you are going to have here is, I just mentioned here, so this one here is total, that is total magnetic induction at the center, I just mentioned as O here, that is 4 into B. So what you are going to have here is 4 into B value, already they have, already we found that value mu naught I divided by root 2 pi into A. Now this one 4, what can mention here is 2 into root 2 into root 2 into mu naught I divided by, you can mention like this is mu naught here, mu naught divided by root 2 pi a. If you multiply this one, you can get 4 over here. So root 2 will be cancelled here. So what you are going to have 2 root 2 mu naught I divided by pi a. So answer in this case. Okay, next, this one also little important. Previous problem, whether this problem in this one you can have this one. See, magnetic induction field at the centroid. Centroid means of an equilateral triangle. In the equilateral triangle at the center, what is that magnetic field? The side what they have given here is L and carry a current here is I. See in this case, first you just see here. This is the length. What they have given here is side length here is L. See, I just mentioned here in all the cases, side length here is, I just mentioned as L here. Here also L, and here is L, right? And here is, this is L by 2 and this one is L by 2. And what they have given here is, this is 60. See this one, this is 30 and this one is 30. The total one is 60 degree and this one is 90. So half of this one here is 30. So 30, see this one is 30, 60 and 90 here. See, I just mentioned here properly. Now this one, this is alpha and this one here is beta here. Similar like this, last this one you just concentrate over here. See here, this is alpha and beta, that is 30, and here also 30 here, and theta 1 and theta 2 here is 60 and 60. And this one, the length what they have given here is L, total length. Now you just mentioned here from this one. See, I just mentioned here, for this you are going to find out what is the magnetic induction due to part C. I just mentioned here, um, magnetic induction due to AB. Because of AB, what is that magnetic induction? I just mentioned here. You just go through the formula. Just now I told this one. This is mu naught I divided by 4 pi into R, right? 4 pi into R, and the sine of, here angle here is 60 degree, sine of 60 plus sine of 60 degree here. But we are not sure about R here. See this one, we are going to find out R. See, they have given, this is the perpendicular distance is R, but we are not sure about this one. We have to find out. Let me tell you here. And sine 60 here is, already you know this one. See, about angle, I just tell you how you are going to find out in the next slide. So this one, don't memorize this, you just memorize what, no need to memorize, you can understand here. I just tell you. So sine 60 here is root 3 by 2. There are two sine 60, so that I just mentioned here, mu naught I divided by 4 pi R into 2 times of root 3 by 2 here. So what you are going to have, 2 will be cancelled here. So from this one, what you are going to have here is root 3 mu naught I divided by 4 pi R. Now this is about 1 along AB. Now this one, in this case, you have to know about R. What is the R value? See, for this one, you just consider over here. In this case, I just try to get a tan of 60 degree. What you are getting here is tan 60 here is I just mentioned here, opposite side, that is AD divided by adjacent side, that is, for example, center I just mentioned as D, O here. So this one is O. So what you are going to have here is AB divided by O. AB value here is not AB, AD value here is L by 2, and divided by DO only we are going to find out. From this one, tan 60 here is already you know this one, tan 60 here is root 3. See, from this one, root 3 is equal to L divided by 2 into this is DO. I just mentioned here. This one here is DO. See, from this one, DO is equal to L divided by 2 root 3. Now this is DO is nothing but that is the distance R. Now from this one, you just substitute the value here. See, from this one, I just mentioned here, B is equal to root 3 mu naught I divided by 4 pi into 4 pi here into R value here is L into, the denominator it will come over here, that is 2 into root 3. See, from here I just cancel this one, this is 2. So what you are going to have here is root 3 into root 3, that is 3 here, 3 mu naught I divided by 2 pi into L, right? This is along only. So this one I just mentioned here, this is along only A and B, and BC is there and AC is there. So what you are going to have, the final one I just mentioned here, that is the previous, like previous one I just mentioned here, B naught is equal to 3 times of B. Now you just multiply here. See, from this one, 3 into 3 mu naught I divided by 2 pi into L, that is 3 into 3 here is 9 mu naught I divided by 2 pi L. Now this one I just mentioned here properly, this is 9 mu naught I. So answer in this case. Okay, now this one, sine of angle, cos of angle, tan of angle. Hope you used to remember the tabular column. From the tabular column 0, 1 by 2, like that, 0 to 1 value will be there. You are going to memorize, right? Now I just tell you a short short way to remember this one, but you need to remember this one. See, for example, in the first case I just mentioned here, in the first case, see, inside all angles are add together in triangle. Suppose if you are going to add all the angles together, what you are going to have here is the total angle here is 180 degrees, right? Now, if the triangle is made into two different angles I just mentioned here. One is about if triangle is differentiate like this 30 is to 60 is to 90 degree. If it is made like this, you always remember this one, that is 1 is to root 3 is to 2, so that opposite angles are should be like this. See this one, for example, I just mentioned here sine of 30 degree, and this is 60 and 90. If this triangle is made into three different like this, if it is made like this, means you have to remember 30 opposite to the direction you have to mention as 1, 60 opposite side you have to mention as root 3, and 90 opposite side you have to mention as 2. Now for this one you just find out here sine of 30 degree. What is sine 30? Sine 30 here is, now you just mention here sine 30 here is opposite side by hypotenuse. For this one you can mention here opposite side here is 1, hypotenuse here is 2. So 1 by 2 is that answer. Similar like this, sine of 60 you just mentioned here, sine 60 here is this one, opposite side here is root 3, and adjacent, sorry, hypotenuse here is 2. Similar like this, cos 30 here is cos 30 adjacent side by hypotenuse root 3 by 2. And even uh, cos 60 here is 1 by 2, you can understand here. Similar like this you can find out the answer. And next one, suppose if this triangle is made like this, now that is separated like 45 is to 45 is to 90. Now you all add together, what you are getting here is 180. In this way also you just add together, you'll also get 180 degree. Suppose this one, if it is 45, this one also 45 you just mentioned here, and that one here is how you are going to differentiate the value here is 1 is to 1 is to root 2. Now you just mention here 1 is to 1 is to root 2 here. Similar concept you just mentioned here, what is sine 45 degree. Now this one, in this case, similar one here is opposite side by hypotenuse, that is 1 by root 2. In previous case, sine of 30 here is opposite side here is 1, and hypotenuse here is 2. So similar, this is the concept, you just remember this one, you can understand. But these 2 points, you just remember these 2 points, you have to remember 30 60 90 here is 1 is to root 3 is to 2, 45 45 90 here is 1 is to 1 is to root 2. Now, next one here is about a solenoid and toroid shape. I just tell you what you mean by solenoid. See, this one solenoid here is it's a wire which is a spiral around. See, like this. This is the solenoid over here. Toroid means, toroid is like a saving bag in swimmers they are using. Now, I will show you that one also a little later. Now, you just concentrate about this one. The length of the solenoid is 0.1 meter, and the diameter is very small. See, diameter is very small, length here is 1 meter. A wire is wound over into two layers. Now the wire is wound into two layers. The number of turns in the inner layer here is, see, there are two layers, one is outer and inner layer, and the inner layer here is 50 turns, outer layer is 40 turns. What they are given, the strength of the current flowing in two layer in the same direction. Current flow will be in the two layer same direction. The value here is 3 ampere. What they are asking, the magnetic induction at the middle of the solenoid. Now this one at the middle of the solenoid, what is that magnetic induction? Now for this you can understand over here. See, for this one, similar concept what you have seen in the previous one. See here, in this case, if you consider about this one, this is alpha and beta, we are going to use the formula mu naught n I divided by, there we are using 2 pi r, right? But here is only 2 is there, sine alpha plus sine beta. And another thing, see here, if the length here is infinite, infinite length means very long length. If this is short length, suppose if you consider the length here is over like this long distance, means the alpha and beta will become 90 and 90. So 90 degree in this case, sine 90 here is 1, cos sine beta, this one also 1 here, 1 plus 1 is 2, 2 2 will be cancelled here. So b is equal to only this value. I just show you here. See, in this case, sine 90 plus 90, what you are going to have here is 2 is there, and this 2 and this 2 will be cancelled here. So only thing is b equal to mu naught into ni. Now it is a point nearer only one end, means this is only one end, this one won't be considered, only one end means this is 1, so remaining thing will be there. Now you just consider here, how can I use this one here is diameter is very small when compared to the length. So you are going to consider the previous one. So according to this, what I'm going to mention here is for this one, the total magnetic induction by the two coil here is I just mentioned here B is equal to B1 plus B2 here. Now this one magnetic field for the B1, just now we have seen the um, formula here. That one I just mentioned here, mu naught. So number of turns here is N1. Current here is the same current, so I just mentioned as I. And second solenoid coil here is mu naught N2 into I. I is the common one. I just take it out. Mu naught also common. Mu naught I just take it out. N1 plus N2. That is 50 plus 40. What you are going to have here is 90. So this one here is 4 pi. Mu naught value here is 4 pi into 10 power minus 7. And the current value what they have given here is 3 into and 90 here. So you just multiply over here. I just mentioned this one. So 4 into 3.14, and the current value and the total number of turns here is 90, and the current here is 3 into 10 power minus 7. Now you just multiply all over there. See, I just show you in this case. See, for 4 into 3.14 and 90 into 3, what you are going to have here is you are going to have 3391 0.2 into 10 power minus 7. This one I just mentioned here. 3 into round of the value 3.4 into 10 power. The 3000 I just take it here. So what you are going to have here is 3 into 10 power minus 4. Sorry, this is 10 power minus 3, 3.3, right? Into Tesla. 10 power minus 3 Tesla. Okay, now the next problem here is the magnetic induction at the center of very long solenoid. Now you just consider solenoid, previous one I have shown. At the center, the value here is B. If the length of the solenoid is off, so length has been reduced into half of this one, and the same wire is wound into two layer. In the in two layer, the new magnetic induction. Two layer, once in this case, if it is formed like a two layer, which is formed like a solenoid in this case. See here, this is about the toroid shape. Once it forms in the two layer. See, if it is in a two layer, means see, you can understand here. This is about toroid shape. In this toroid shape, the length will be forming like this. See, the field inside and outside of the core will be always equal to 0. But at the center, the value already they have given. This is about the center one. Outside and inside, this is 0 here. See, BQ and BR, that value. Just remember this point, highlighted points. They will ask you as a concept oriented questions. These two are will be asked here. From the center and outside, magnetic induction is 0, but at the center here is they have given that value here. See, according to this I just mentioned here, remember this one, you can understand. See, I will tell you in this case. See, for the first one, the total magnetic induction what they have given here is B is equal to mu naught N into I. Now this is about in this case B value. Now this one what they have given here is length has been reduced from the reduced one, which has been made into toroid like a shape, or even a that is reduced into half and made wound into two layers. Two layers you can understand here. In toroid shape only you can understand two layer in this case. At the center of this one, what you are going to have here is mu naught Ni divided by L here. Now from this one, in this case, what you can understand here is this is not depend on the number of turns. It mainly depends on the length. See, for this one, first one I just mentioned here, B1 divided by B2, that one will be equal to, I just mentioned here, L2 divided by L1, because this is inversely proportional. B1, if you mention this is L1, B2 here is B1 by B2. I'm sorry, this one B1 by B2 here is L2 by L1. Now you just substitute here L2 value, which has been reduced into of L by 2, and the L1 value here is L. So LL will be cancelled here. So from this one, B1 is equal to 1 by 2 into B2, or even B2 here is 2B1. Already they have mentioned B1 value. That is the first one, that is 2B. So answer in this case 2B. The next one here is see here, a long solenoid has 200 turns. So N value given 200 turns per centimeter here, and carries a current I value given. When a current flows through the solenoid, it produces a magnetic field at the center here is they have given 6.28 into 10 power minus 2 Weber per meter square. And another long solenoid here is the same. 100 turns per centimeter. See, both are in centimeter, means no need to convert because centimeter will be cancelled here. And it carries a current of, but here it's reduced into half. So that means another one is half of this one, and the current value has been reduced. Next one, the magnetic field induction. In this case, what is the magnetic field induction? See, in this one already they have reduced the number of turns, they have reduced the current, then definitely that value should be less than that one. Already all the values are less than only. So now we are going to find out this one. Let me tell you here. The first one I just mentioned here. For example, what is the formula in case of solenoid? Here is B is equal to mu naught N into I. So mu naught value is constant, it's not going to change. N and I only is going to change. For this case, I just mentioned here B1 is proportional to N1 I1. Similarly, I1 here. Similarly, in case of B2 here is B2 is proportional to N2 I2 here. So what they are asking, B1 value already given, B2 values they are asking here. See, from this one, B1 divided by B2 will be equal to N1 I1 divided by N2 I2 here. I just mentioned here N2 I2. Now substitute the value here. N1 value here is first one, that is 200, and divided by second one here is 100, and the first one high value here is high, second value here is I by 3. Now you just cancel this one, 200 200 here, this will be cancelled here, only 2 is there. And see here, so what you are going to have here is 1 by 3, it will become 6 over here. And this one B1 by B2, B1 value already they have given 6.28 into 10 power minus 2, right, and divided by B2 value here. Now that one will be equal to what they have given here is 6 here. See, from this one I just mentioned here, from this one B2 is equal to, B2 here is 6.28 into 10 power minus 2 divided by 6. So you just divide this one, what you are going to have here is 1 time, and this is 0, and 4 here 5 times into 10 power minus 2 Weber per meter square. So answer in this case. Okay, now next one, this is about the toroid as a core inner radius. See, inner radius they have given 21 centimeter, outer radius that is a 23 centimeter. I just show you. See, this is about from here to here. See, you just consider from this one, inner radius here is 21 and outer radius here is 23 centimeter, around which 2000 turns, number of turns of solenoid is made up of toroid here is solenoid that made into a toroid here is 2000 turns. If the current in the wire, so wire current value they have given 11. What is the magnetic field outside of the toroid, inside of the core of the toroid, and the empty space? See here, outside that is R, inside that is Q. So already I told this one, outside and inside here is 0. Now this one, see here, this one outside and inside, two answers they have given. Outside and the center here is 0. In all the case, so this answer won't be there. This answer will be there, or even this answer will be there, and B and C won't be there. You can avoid these two answers, right? See, outside and inside, from this one you can reduce whether this one or this one. Next one, what they are asking in this one, at the empty space, now we are going to find out here. See, for this one, let me tell you in this case, first one, what is the formula to find out here is, just now we have seen this one, B is equal to mu naught N I divided by 2, this one, mu naught N I divided by 2 pi r, and mu naught value already you know this one, 4 pi into 10 power minus 7. N here is, that is 2000 turns, and I value that is 11 ampere of current, and 2 pi into, and R value, what is that, radius at the center, in this case solenoid at the center. See this one, this is outer radius, and for example this is the inner radius I just mentioned here, inner one, this is outer one. In between the center, that is about the center one, that radius here is, I just mentioned here, R is equal to R1 plus R2 divided by 2. Now in this case, R1 value here is 21 plus 23 divided by 2. What you are going to have here is 44 by 2, that is 22 centimeter. 22 centimeter here. See this one I just mentioned here, 22 into 10 power minus 2. See, from this one, see, you just cancel here, for this one here is 2 times, right? And again you just cancel this one, 2 here, that is 11 times, and 11 times 11 times will be cancelled here. See this one, 10 power minus 2, if it is come here, that is 10 power plus 2, that is already 2000. Here is 2 into 10 power 3, this one is 10 power 2, already you are having 10 power minus 7. So what you are going to have here is 2 into uh, this one I just mentioned here, 2 into 10 power 5, if it is gone means 2 into 10 power minus 2 Tesla. So answer in this case here is one little long chapter, still more problem is there. Let me continue that important problem on this one, and even there are some of the cases like force between the parallel current and even a tangent galvanometer. That and all we are going to see in the next chapters. We'll see. It will be continued. You just subscribe our channel so that you can get a continuous and even I'll get the support and you will get a continuous update from this one. Thank you.